All right, here's the third video for section 8.1. What we're going to be doing in this section is using a special notation called summation notation to write our series and sequences. So here we've got two series. You'll see one is a finite series and the other is an infinite series, which again, finite series is designated by having an ending value, and a finite series has the ... at the end, indicating that this goes on and on infinitely. So to understand summation notation, I'm going to go to the journal. This is one of the core concepts. It's on page 219 under series and summation notation. Now you'll see our finite series, infinite series that I just mentioned. So an ending value versus an ongoing value. Now, summation notation looks like this. You've got this Greek letter sigma that is written here. And what happens is we use sigma to notate that it is a series or sequence. We have our lower limit and upper limit on the top and bottom. And we have our rule written here on the right-hand side. So again, this is called summation notation. We have our rule, and the index of the summation is the letter I. So we have our rule on the right-hand side, which, in this case, our example is just the even numbers. So our rule is 2I, where I is just the index of each value. So this first one would be our first, so I equals 1. This is our second, I equals 2. Third, I equals 3. So the way that our lower limit and upper limit would work is we start at I equals 1. That's our first value. And since there's 4 numbers in this sequence, we go from 1 to 4. So taking each value here as we go from our lower limit to upper limit would produce this finite series. Now in an infinite series, the only thing that changes is we don't have an upper limit. So it just goes on and on continually. So our upper limit would be infinity. So the difference between a finite and infinite series in sigma notation is that our upper limit is, instead of a number, it's infinity. Now down here you've got some formulas for special series. We're not going to do those right now, but you can look in here and see them. The sum of the first terms of 1, sum of first n positive integers, sum of the squares of the first n. These are helpful to know because they can help you out when you see certain patterns. Now let's go back here. Let's look at these two series using summation notation. You'll notice one is finite, the other is infinite. Let's go ahead and work through this. So in this one, we notice that as we're starting to notice how to read patterns, we notice this is just 25 times 1, 25 times 2, 25 times 3, all the way up to 25 times 10. So we can write this series as A sub I equals 25I, where our I values are the finite series 1, 2, 3, all the way up to 10. So 1 through 10. Now with all these series, we're trying to look for a rule where we get a number times a counter. So 1, 2, 3. So trying to find how we can do our rule to each counter term so we can write it as a series or a rule. So here, since we have a lower limit, which is I equals 1, and an upper limit, I equals 10, in summation notation, we would write this as our sigma sign. On bottom, I equals 1, that's our lower limit. Our upper limit is 10, and our rule is 25 times I. If we would take this out and write it, starting out with 1, and having each value in our series go up from I equals 1, going each number to I equals 2, I equals 3, all the way to 10, we would get all the values in this series. Now for our next one, we notice, first of all, this is an infinite series. So the upper limit of our summation notation is going to be infinity. We're starting at a fraction, 1/2 plus 2/3 plus 3/4 plus 4/5. Now, if you try to look and see what pattern or what notation we have, we always have our numerator is always 1 less than our denominator, or our denominator is 1 more than our numerator, depending on how you want to look at it. So for each term here, we've got a rule right here. Our fraction is just our I value over I plus 1. If we start out with I equals 1, we've got I over I plus 1. For our second term, we have I over I plus 1 when I equals 2, plus I over I plus 1 when I equals 3, and so forth. So again, when you start I at 1 and you count up, this gives us a good rule right here. We have our index over our index plus 1. So for our summation notation, remember, since the lower limit is 1 and the upper limit is infinity, we would write this as sigma with our lower limit of I equals 1 to our upper limit of infinity, and our rule is I over I plus 1. So what I want you guys to do here, if we go to do an example, this one, I want you guys to write each series using summation notation. However, we don't have the sigma notation. So what I want you guys to do for each of these, I want you to separate them by part A and B. I want you to tell me the lower limit, the upper limit, and the rule. So for this example back here, for our first one, our lower limit is 1, our upper limit is 10, and our rule is 25i. For our second one, our lower limit is 1, upper limit is infinity, and our rule is I over I plus 1. Those are the things I want you to tell me for both of these. So make sure when you input these, do A, lower limit, upper limit, rule. Then do B, lower limit, upper limit, rule. For infinity, just write in infinity.